Properties of an element. The properties of an element are as follows. First, the number of electrons present in all isotopes of an element is the same. These isotopes have same electronic configuration, that is arrangement of electrons in various energy levels of an element. Let's take an example. The isotopes of hydrogen are protium, deuterium and tritium, and all these hydrogen isotopes have same number of electrons, that is 1. Next, the chemical properties of these isotopes of an element are identical. The chemical properties of an atom of element depends on the number of electrons and not on the number of neutrons. Since all the isotopes of an element contain same number of electrons, therefore they have identical chemical properties. Again the same example, protium, deuterium and tritium have same chemical properties because they have same number of electrons. Now let's understand about the physical properties of isotope. The physical properties of all the isotopes of an element are different because physical properties of element depend on mass of the atom. As the isotope of an element have different number of neutrons, they have different masses, and since isotopes of element have different masses, therefore their physical properties are also different. So we can say that isotopes of element have different densities, melting points and boiling point because all these are the physical properties and they depend on the mass of the atom. Now let's understand the arrangement of electrons in various energy shells, that is the electronic configuration. The arrangement of electrons in various energy levels or shells of an element is called as electronic configuration. In order to know how the electrons are distributed in various shells of the atom of an element, we must know its atomic number. Once we know the atomic number, we follow the scheme given by Bohr and Berry. According to this scheme, the maximum number of electrons which can be accommodated in any shell of an atom is given by 2n square, where n is the number of shells or energy levels. This can be explained as follows. For the first shell, that is K shell, n is going to be 1 and the maximum number of electrons are going to be 2. That is 2 into 1 square, that is going to give us 2. Next is for the second shell, that is L shell, n is going to be 2 and here n square is going to be 4 and 2n square is going to be 2 into 4, that is equal to 8. Hence the maximum number of electrons in second shell is going to be 8. After that we have third shell for which n is going to be 3 and maximum number of electrons are going to be 2 into 3 square. 3 square is 9 and 9 into 2 is going to be 18. Hence in M shell there are total of 18 maximum electrons. After that we have fourth shell, that is N shell, and in N shell n is going to be 4 and 2n square, that is 2 into 4 square. 4 square is 16 and 2 into 16 is going to be 32. Hence the maximum number of electrons in fourth shell are going to be 32. However, the maximum number of electrons that can be accommodated in the outermost shell of any atom is 8. Electrons in an atom cannot go to the new shell unless the inner shells are completely filled with electrons. Now let's follow the above scheme to write the electronic configuration of an atom of hydrogen, that is the first element. It has atomic number 1, mass number 1, number of protons 1, number of neutrons 0 and number of electrons 1. Only one electron has to be accommodated, so it will go in the first shell, that is K shell, and hence the electronic configuration will be K1. Here we have elements and their electronic configuration. First element is hydrogen, symbol is H. atomic number is 1 and one electron will be entering K shell, and since K shell is the outermost shell, its valence electron is also 1. Next element is helium, symbol is He, atomic number is 2 and both the electrons will enter K shell, hence its electronic configuration is K2. Next we have the valence electrons. So since K shell is the outermost shell, the number of valence electron in helium are 2. Next is lithium. Symbol is Li. Atomic number is 3. Its electronic configuration is K2L1 and valence electron is going to be 1, which is present in L shell. Next is beryllium. Symbol is Be. Atomic number is 4. Electronic configuration is K2L2. L being the valence shell, the valence electrons are 2. Next is boron. Symbol is B. Atomic number is 5. Electronic configuration is K2L3. L being the outermost shell, the valence electrons are going to be 3. Next element is carbon. Symbol is C. Atomic number 6. Electronic configuration K2L4 and valence electrons are 4. Next is nitrogen. Symbol is N. Atomic number is 7. Electronic configuration is K2L5 and valence electrons are 5. Next is oxygen. Symbol is O. Atomic number is 8. Electronic configuration is K2L6 and valence electrons are 6. Next is fluorine. Symbol is F. Atomic number is 9. Electronic configuration is K2L7 and valence electrons are 7. Next is neon. Symbol is Ne. Atomic number is 10. Electronic configuration is K2L8 and valence electrons are 8. The next element is sodium. Symbol is Na. Atomic number is 11 and electronic configuration is K2L8 and M1. M being the outermost shell, valence electron is also going to be equal to 1. Next is magnesium. Symbol is Mg. Atomic number 12. Electronic configuration is K2L8 and M2 and valence electrons are 2. Next is aluminium. Symbol is Al. Atomic number is 13. Electronic configuration is K2L8 M3 and valence electrons are 3. Next we have silicon. Symbol is Si. Atomic number is 14 and electronic configuration is K2L8 M4 and valence electrons are 4. Then we have phosphorus. Symbol is P. Atomic number is 15. Electronic configuration is K2L8 M5 and valence electrons are 5. The next element is sulfur. Symbol is S. Atomic number 16. Electronic configuration K2L8 M6. Valence electrons are 6. Next is chlorine. Symbol is Cl. Atomic number is 17. Electronic configuration is K2L8 M7 and valence electrons are 7. Next is argon. Symbol is Ar. Atomic number is 18 and electronic configuration is K2L8 M8 and valence electrons are 8. Then we have potassium. Symbol is K. Atomic number is 19 and electronic configuration is K2L8 M8 and N1. Since N is the outermost shell, valence electron is 1. Next is calcium. Symbol is Ca. Atomic number is 20. Electronic configuration is K2L8 M8 N2 and valence electrons are 2. Here we have electronic configurations of some elements and the numbers in the bracket are atomic numbers of element and the number in the innermost circle are the numbers of neutrons and protons. Let's take few examples. Hydrogen has one proton and one electron. Helium has two neutrons, two protons and 2 electrons. Lithium has 4 neutrons, 3 protons and 3 electrons. Beryllium has 5 neutrons, 4 protons and 4 electrons. Boron has 6 neutrons, 5 protons and 5 electrons. Carbon has 6 neutrons, 6 protons and 6 electrons. Similarly, for all other elements, we have nitrogen with 7 neutrons, 7 protons, 7 electrons, oxygen with 8 neutrons, 8 protons and 8 electrons, fluorine with 10 neutrons, 9 protons and 9 electrons. Neon has 10 neutrons, 10 protons and 10 electrons. Sodium has 12 neutrons, 11 protons and 11 electrons. Magnesium has 12 neutrons, 12 protons and 12 electrons. Aluminium has 14 neutrons, 13 protons and 13 electrons. Silicon has 14 neutrons, 14 protons and 14 electrons. Phosphorus has 16 neutrons, 15 protons and 15 electrons. Sulfur has 16 neutrons, 16 protons and 16 electrons. Chlorine has 18 neutrons, 17 protons and 17 electrons. And last, argon has 22 neutrons, 18 protons and 18 electrons.